Hi, my name is Oskar Rosenstam and I am a product owner at Consat Telematics. Consat Telematics is the largest ITS supplier originating from Scandinavia. We have been in the industry since 1989 and we believe in delivering large system solutions over niche products. Our headquarters is in Gothenburg, Sweden, and our largest markets are Scandinavia, Canada and Australia. And today I want to talk to you about our experience working with electromobility. Norway has for a long time been a front runner when it comes to electromobility, both for private cars and public transport. Here are some headlines from some of the most well-known media houses around the world. And the shift to electromobility is not happening in Norway. It has already happened. And Consat Telematics is the main supplier to 5 out of 6 of the largest bus operators in Norway. So this means that we've been involved in this process from the beginning and throughout where we are today. And based on that, I want to share with our experience because of course we learned a lot during this process. As a bus operator, a lot of things is about doing optimizations. That you need to fulfill the service levels in your traffic contract with a minimum number of buses and drivers, etc. This is how you compete and this is how you do business. And usually you start off by setting a plan involving all your resources. A plan with safety margins, of course, but you always need to be able to act when something happens, when disturbances occur. So let's say that you have a fleet consisting of only diesel buses. And when something happened to one specific bus, you can usually handle that without affecting the other buses, meaning that the disturbance is kept local. Let us now sprinkle in some electric chargers and turn this fleet into a fleet of e-buses, which also mean that you have not only optimized the number of buses, but you also optimize the number of chargers and the battery capacity for each bus, which is a huge difference compared to the diesel buses where you never optimize the volume of the diesel pack. And let's say now that one of the buses have a heavy delay. And when it finally gets to a charger, it still needs to charge for the same amount of time as planned, because otherwise it won't make its assignment. And by doing that, it occupies the charger longer than planned, meaning that other buses will have to wait in line for their turn, causing delay for them as well. So this disturbance isn't local. And my point here is that operations of an e-bus fleet is more like handling a system where disturbances can spread within the system. So setting up the plan is the easy part when working with e-buses. Handling the operations is the hard part. And I want to share with you a 4-step model of how to take control of your operations with e-buses, which is based on our experience here at Consat. Step 1, sufficient charge. It's important that you know the sufficient charge needed for each individual vehicle to make its individual assignment. And here is a picture from a car where you can see the number 202 kilometer, which is an estimate of how far you will reach with that current battery charge. But a typical car manufacturer don't know very little about the future, because the car usually don't know where you are supposed to be driving. It doesn't know what route you will take, or a lot of other factors that had a huge impact on of what the actual range with this battery level actually is. And here comes a big advantage working with public transport, because we usually work with planned traffic and fixed routes. And when you look at the lines, you also quickly realize that many segments are not only for one line, but are shared by many lines, meaning that we can get a lot of data points, meaning that we don't not only have to look at the specific bus model and the bus line, but we can also see other factors affecting the energy consumption, like number of passengers on board, the ambient temperature, the driver's individual driving style, the level of traffic combustion, or if the heater or cooler is active or not. So thanks to this, we are able to make good estimations of the future based on this historical data. And due to real-time data, we can make sure that these estimations are up to date when things change. So, step 1, sufficient charge for each individual vehicle and each individual assignment. Step 2, charger control. You need to have control of your chargers, and charging is often a bottleneck when it comes to electromobility. It can be both the number of available chargers, but also that you have a specific output limit for an individual or a group of chargers. Either way, you need to have control of your chargers, being able to operate them remotely, and know what statuses they have. So some examples here could be that, for instance, you at a depot have a maximum level of total output level that you don't want to exceed. And in order for one charger to use maximum effect at one given moment in time, then you need to lower the effect for other chargers. Or it could be that you have some specific superchargers that you only want to use when they're absolutely needed. Or it could be that you want to take into account what is a spot market price of when you decide when to charge. Either way, you need to have control of your chargers. And step 3, surveillance. You need your system to detect when something deviates from plan. When it happens, not when you see the consequences. Because something can happen early in the morning that you don't see the consequences until later in the evening, when it's too late to act. So as an example, I want to present this simplified charging plan for one specific vehicle. The y-axis is the charge level and the x-axis is time. So when the bus is driving, the charge decreases. It's stable when the bus is waiting, and during the charging sessions you increase the charge, which is highlighted with the color yellow here. So this is the plan, and then we see this outcome or what will happen. What I want to highlight here is this. For some reason, the bus starts charging later than planned. The reason could be something as simple as the driver just forgot to put in the connector. But anyway, when the charging starts, it reaches a certain level which is okay to make the next assignment, meaning that you won't discover anything yet. And then you do charging session 2, which goes according to plan, how much that you charge. And then it's the third assignment of the day, when you're by the end of that assignment, you suddenly realize, oh, I don't have sufficient charge to reach my destination. So it could be that the system didn't detect until very late that you don't have sufficient charge, but you should have been warned when this happened, because that was the time for you to act, to be able to solve this problem with minimal impact to the other parts of your system. So it is crucial that you have surveillance that detect when things deviate from plan at the correct time. And with this, we can go to the 4th step, the adjustment of the plan. Because when you have the other three steps, which is the sufficient charge level needed for each individual vehicle and each individual assignment, and when you have control of your chargers, and when your system detects that something deviates from your plan, then you have the possibility to make an adjustment with this new input. And this is how you take control of your operations with e-buses. And the 2 main takeaways here, I would say, would be, first of all, that This operations with e-buses is a very complex system where you must remember to also see the IT system as a part of this full system, and that your IT system must be able to handle all the 4 steps I just talked about. And lastly, that I've been mentioning a lot of different factors affecting the energy consumption of the buses, and it's actually only one of those factors that you as a bus operator can affect throughout the contract, and that's the driver's individual driving style. So when focusing on technology and IT systems, don't forget the human behind the steering wheel. Don't forget the driver. Thank you.